Good morning children. So in the atomic structure lesson, this session we are going to discuss about ions, types of ions. In the two types we are going to see, one is the anions and another one is cations, followed by valency of ions. Here also we are going to discuss about two. One is about positive radicals and another one is negative radicals. Next, chemical formula or molecular formula. Next one is naming chemical compounds, followed by laws of chemical combination. Okay, in the two laws we are going to discuss. So these things we are going to discuss in this session, children. First, let me move to the ions. You know very well an atom is electrically neutral because the number of protons as well as number of electrons are equal. Hence, an atom is electrically neutral. When an atom attains stable electronic configuration, when an atom attains a stable position in the electronic configuration, either by losing electrons or by gaining electrons, right? When an atom gains an electron, when an atom gains an electron, it has more number of electrons, so it carries negative charge. Why? Because electrons are negatively charged particles. You know, isn't it? You know about the subatomic particles. The three subatomic particles are protons, electrons and neutrons. Protons are positively charged, electrons are negatively charged particle and neutrons carry no charge, they are neutral in nature, right? So, if an atom gains an electron, when an atom gains an electron, it carries negative charge. Why? Because it has more number of electrons in it, right? At the same time, if an atom loses an electron, it has more number of protons, hence it carries positive charge, right children? Gains an electron means negative charge, at the same time loses an electron means positive charge, right? So, an atom which consists of positive charge as well as negative charge are called ions, right children? What are called ions? And atoms which consist of both charges, that is positive charges as well as negative charges are called ions, right? Okay, so ions, I told you about the positive charge as well as negative charge. While writing the electronic configuration, first we have to mention the ions, that is negative sign as well as positive sign as a it is in the superscript that I will tell you while writing the chemical formula, right? So an atom or group of atoms either gaining or losing electrons, it can be converted into ions or radicals, right children? Good. So it's a 2 mark question. What are called ions means what's the answer? Atoms which carry both negative charge as well as positive charge are called ions, right? Next we can move to the types of ions. There are two types of ions. One is the anions and another one is the cations. So one is anions, another one is cations. What is the difference between anions and cations? First, let me discuss about the anions. During chemical reaction, during chemical reaction, an atom or group of atoms, they gain an electron or otherwise group of electrons. During chemical reactions, an atom or group of atoms, they gain either a single electron or otherwise group of electrons. So these are called, that time what happens already I told you, it has more number of electrons present in that atom, so it carries negative charges, isn't it? These charges are called the anions. These are called the anions, or otherwise we can say negative radicals, right children? For example, example, we can take the chlorine atom. Okay, so what is the atomic number of chlorine? The atomic number of chlorine is 17, right? So this is the nucleus. Here 17 protons as well as 17 neutrons are present. You know very well in the nucleus what is present? Protons as well as neutrons are present. Okay, what is the atomic number of chlorine? 17. So protons as well as neutrons are present here. 17 in number, right children? Good. Here, if you look at the outermost orbit, here how many electrons are present? 1, 2, 3, 4, 5, 6, 7. 7 electrons are present. Here, what I told you, when an atom gains an electron, okay, when an atom or group of atoms gains an electron, it changes into ion. Okay, so look at this one, plus 1 E minus means 1 electron. E minus means it is nothing but electron, gaining of an electron. Okay, so chlorine attains stable electronic configuration by gaining 1 electron, right? So this is nothing but the chlorine atom and its symbol is Cl. This chlorine atom attains stable electronic configuration by gaining 1 electron and turns into chlorine ion. Okay, ion, that is Cl minus. Its formula is symbol is Cl minus, right children? If you look at the if you look at the valence electrons in the outermost orbit, count 1, 2, 3, 4, 5, 6, 7, 8 valence electrons are there. Valence electrons means what? The outermost orbit valence the electrons are revolving, no? So these are called the valence electrons. So chlorine attains stable electronic configuration by gaining 1 electron, right children? These are called anions, or otherwise we can say negative radicals, right? So this chlorine ion, it can be represented as Cl minus. Understood children about the anion, right? Shall we move to the cation? Good. Next we can move to the cation. Here also, during chemical reactions, okay, an atom loses an electron. An atom or group of atoms loses an electron. Okay, that time what I told, more number of protons will be there, so it carries positive charge, isn't it? So these are called the cations. Okay, for example, we can take the sodium atom. Okay, what is the atomic number of sodium? The atomic number of sodium is 11. So 11 protons as well as neutrons are present in the nucleus, right? So sodium atomic number is 11, isn't it? Here, this sodium atom attains stable electronic configuration by losing an electron. So here see, this sodium atom loses 1 electron, that is minus 1 E minus. Okay, that is it loses 1 electron and turns into sodium ion. This Na minus, this sodium ion is represented as Na minus. Understood children? Now you understand that understood the difference between the cation as well as anion. This we can say cations, or otherwise we can say positive radicals. Understood? Right? Shall we move to the next one? Good. What is the next one? Next one, valency of ions. Right? Ions can be classified into monovalent ion, divalent ion, trivalent ion, tetravalent ion, like that, based on the number 1, 2, 3, 4, like that. Okay. First, let me discuss about the positive radicals. Okay, negative radicals as well as positive radicals are there. Here, both anions as well as cations we are going to discuss now. Actually, first of all, you should know the what is the difference between monovalent ion, divalent ion. I told you, valency of ions, it can be classified into various types, that is monovalent, divalent, trivalent, like that. First we can see the monovalent ion. What is meant by monovalent ion? An element with valency, or otherwise an element with a valency 1 is called monovalent ion. Okay, an element with valency 1 are called the monovalent ion. For example, we can take sodium and potassium. If you take sodium element as well as potassium element, its valency is 1, right? So we can say the sodium and potassium as monovalent ion because these elements contain only one valency. Next one, we can move to the divalent ion. Divalent ion means elements which contains valency 2. These are called divalent ions, right? For example, calcium and magnesium we can say as an example for divalent ion. Okay. Next one, what I told, trivalent ion. Trivalent ion means what? Elements with valency 3 or 3 valency are called trivalent ion. For example, we can take aluminium, boron. Right, children? Now you know the difference between monovalent ion, divalent ion as well as trivalent ion. Good. Now we can move to this chemical radicals, that is positive as well as negative radical. Okay. Actually, it is defined as the number of hydrogen atoms. Okay. It is defined as the number of hydrogen atoms and also other monovalent atoms. I told you, sodium, potassium, like that. It is defined as the number of hydrogen atoms or the number of monovalent atoms which is present in that atom. Okay. For example, we can see, look at this tabular column, valencies of some anions as well as valencies of some cations. Okay. Here, if you look here, what are the things are given? Compound, anion, its formula as well as its valency is given, right? So, if you take the first one, here, one hydrogen atom combines with one chlorine atom to form the compound hydrogen chloride. Got it? One hydrogen atom combines with one chlorine atom to form this compound hydrogen chloride. Here, what is the anion? The anion is chloride. This Cl is the anion here, and what is the formula for this Cl? Formula for this chloride? Cl minus. Okay. And what about the valency of chloride? That is 1. Okay. In this manner, we have to write the valencies of anions. Second one we can take. Already I told you we have to count the number of hydrogen atoms or otherwise the monovalent atoms like sodium, potassium, next to chlorine. I told you some examples, boron, aluminium, like that. Okay. Second one we can see here, two hydrogen atoms combines with SO4 2 minus. This SO4 2 minus is nothing but the sulfate ion. Okay. So these two combines to form the compound sulfuric acid. Okay. So what is the formula for sulfate? SO4 2 minus. The formula of sulfate ion is SO4 2 minus and its valency is 2. Why? Because this sulfate SO4 2 minus combines with the two hydrogen atoms. So the valency here is 2, right? In the same manner, we have to calculate the HNO3. Here, one hydrogen combines with NO3 minus, that is nitrate ion. Okay, NO3 minus is nitrate ion. These two combines to form the compound nitric acid. Got it? And what is the valency? The valency of hydrogen is 1 because this nitrate combines with one hydrogen atom. Understood, children? Right. Next we can move to H2CO3. So here two hydrogen atoms combines with CO3 2 minus. This CO3 2 minus is nothing but the carbonate ion. Okay. So this H2CO3 is nothing but the carbonic acid and the valency of this carbonate ion is 2 because this carbonate combines with two hydrogen atoms. Understood, children? Right. Next we can move to H3PO4. Here 3 hydrogen atoms combines with PO4 2 minus. This is nothing but the phosphate phosphate ion, and the valency of phosphate ion is 3. Why? Because this phosphate combines with the 3 hydrogen atoms and forms the compound phosphoric acid. Understood, children? Like that we have to calculate for cations. For example, we can take NaCl. Okay, here one chlorine atom combines with one sodium atom to form the compound sodium chloride. And what is the cation here? Sodium is the cation here, isn't it? Because it is a cation. Cation means what? Positive charge. Whereas anion means negative charge, isn't it? So a sodium is the cation and the formula of sodium is Na+. Then what is the valency? Valency is 1 because it combines with 1. Sodium combines with 1 chlorine atom. So the valency of Na+ is 1. Okay. So next one, KCl. Here one chlorine atom combines with 1 potassium atom. Okay, and here the cation is potassium and its formula is K+. Valency is 1 because it combines with potassium combines with how many chlorine atom? Only 1 chlorine atom, right? Next one, NH4Cl. Here one chlorine atom combines with ammonium, that is NH4+, and its valency is 1 because NH4 plus combines with only 1 chlorine atom, so its valency is 1, and the compound is ammonium chloride. This one is potassium chloride. This NaCl is sodium chloride. Next one we can see MgCl2. Okay, here 2 chlorine atoms. 2 chlorine atoms. You have to look at the formula. Okay, twice. Then only you can find out the valency. Here 2 chlorine atoms combines with 1 magnesium atom. And the cation is magnesium. The formula is Mg2+. Its valency is 2. Why? Because magnesium combines with 2 chlorine atoms. Got it, children? Right. And the last one is CaCl2. Here also 2 chlorine atoms combines with 1 calcium. And the cation is calcium. Its formula is Ca2+. And its valency is also 2. Why? Because calcium combines with 2 chlorine atoms. Understood, children? Right. So in this manner we have to calculate the cations as well as anions. First of all, you should know about the charges, whether positive charge or negative charge. For cation, what we have to do? For cation means we have to use the positive charge, and for anion we have to use the minus charge. Okay, in this manner we have to write the balances. Clear, children? Right. Shall we move to the next one? Good. So what is the next one? Next we can move to chemical formula or molecular formula. What is meant by chemical formula? So chemical formula, it is nothing but a shorthand notation of a molecule. Okay. So it mainly used, this chemical formula is mainly used to find out the number of atoms which is present in the molecule of a substance. Okay. Actual number of atoms, what a chemical formula is nothing but it is used to identify the actual number of atoms which is present in the molecule of a substance, right? While writing the chemical formula, we have to follow some steps. 3 steps are very important while writing the chemical formula. What are the 3 steps? First, what we have to do? Step 1 is write down the symbol of elements. Okay, so an element will be given to you. So you have to write down the symbol of elements. First we have to write the symbol of elements side by side. Okay, both the radicals will be there. Positive radicals also will be there in the same in one element, and negative radicals also will be there. So first to find out the positive radicals you have to write in the left hand side, and the negative radicals you have to write in the right hand side. That is the first step. Okay, what's the first step? You have to write the symbol and write down the positive radical in the left hand side, write down the negative radical in the left hand side. What is the second step? We have to write the balances above their symbols to the right as superscript. Okay, so next what we have to do? We have to write the balances of the elements. Symbols already we have written, isn't it? That we have to write that particular element's valency at the right side. That we can take as a superscript. Okay, right. That is the second step. And what is the third step? We have to interchange the valencies. Okay, I'll tell you one example. We can take the calcium chloride. Okay, what is the first step I told? First we have to write the symbol, isn't it? So the symbol of calcium chloride is CaCl. Okay, so Ca is the positive radical. So positive radical, it should be in the left hand side, and the negative radical Cl is the negative radical, so it should be in the right hand side. This is the first step. Second step, what I told you, we have to write the valencies. So the valency of calcium is 2. This is at the right, okay, the right side top we have to write. This is called the superscript. So Ca2, and for the valency of chlorine is 1. So Ca2Cl1, at the right top we have to write. This is the second step. What I told you for third step, we have to interchange the valency. Interchange the valency means this valency will come here, this valency will go there. So what is the final answer? CaCl2. Okay. So 2 here we should not write at the top, we should write down. This is the initial step as well as final step we have to follow for molecular formula or chemical formula. In your book, some activities given. Okay, some elements given. So you have to write the chemical formula for that elements based on a valency and a symbol. Okay, that activity we will do in our classroom. We will do it as a classroom activity. Right, children? Good. Shall we move to the next one? Okay. Next one is naming chemical compounds. What do you mean by compound? Generally, a compound is composed of 2 or more separate elements. This is called a compound, isn't it? We have to name a compound. While naming a compound, we have to follow some steps. What are the steps? First one, in naming a compound, we have to identify in that compound metal also will be there, metallic elements as well as non-metallic elements will be there. So in naming a compound, first metallic elements should be written, okay, followed by the non-metallic elements, right? First what you have to do, we have to write the metallic elements, second one non-metallic elements. Next we have to add the suffix also at the end. Okay, we have to add the suffix IDE. This is the first step. For example, see the first example, NaCl. NaCl is nothing but sodium. Okay, it is a metal. Sodium is a metal. First we have to write the metal. Second only we have to write the non-metal, isn't it? So this one is sodium. Sodium is a metal. First we have to write the metal. Second one Cl. Cl is nothing but chlorine, isn't it? Chlorine is nothing but a non-metal. First metal, second non-metal. And after that what we have to do? We have to add the suffix IDE. Okay. So now name this chemical compound. What is this? NaCl is nothing but sodium chloride. Sodium is a metal. First we have to write. Chlorine is a non-metal. Second we have to write. Next we have to add the suffix IDE. So what is the name of this chemical compound? The name of this chemical compound is sodium chloride. Right, children? And second one AgBr. Ag is nothing but silver. Silver is a metal and bromine is a non-metal. Next what we have to do? We have to add the suffix IDE, isn't it? So what we have to write? Silver bromide. So NaCl is sodium chloride. And second one is silver bromide. This is the first one. Okay. What's the second one? Second one, in naming a compound, as usual we have to name the first metal. Okay. Followed by we have to return the name of the non-metal. We have to write the name of the non-metal with oxygen atoms. Okay. After that, finally what we have to do? We have to add the there, we have to add the suffix ite, right? So Na2SO4. So Na is nothing but sodium and SO4 is nothing but sulfate. Okay. So here how many oxygen atoms are there? 4 oxygen atoms are there. More number of oxygen atoms. So we have to add the suffix Ate. Okay. So what is the name of this chemical compound? Sodium sulfate. And next one NaNO2. If you look at this compound, only 2 oxygen atoms are there, isn't it? So less number of oxygen atoms means what we have to write? We have to add the suffix Ite. So what is the name of this compound? Sodium nitrite. Okay. Next one, the third one. In some compounds, we have to add the prefix, that is mono or di or tri, like that at the center. Okay. So if you look at this one, this is sulfur. S is sulfur and O is oxygen. Here we have to use the prefix sulfur dioxide. Okay, SO2 means what? Sulfur dioxide. And N2O5, here N is nothing but nitrogen. 2 nitrogen atoms are there, isn't it? So what we have to do? We have to write the suffix. Okay, dinitrogen. 5 oxygen atoms are there, so pentoxide. Okay, so dinitrogen pentoxide. The name of the chemical compound is dinitrogen pentoxide. Like that, we have to write the name in the chemical compound. Here, for this also we have one activity part in the book. That activity, many compounds are given. We have to write their names. We can do it as a classroom activity, right, children? Next, we can move to the last one. Laws of chemical combination. What do you mean by laws of chemical combination? John Dalton, Lavoisier and many scientists formulated many laws based on the composition of matter, right? What do you mean by matter? Anything which occupies space and has weight are called matter, isn't it? These laws are called the chemical combination. In your book, actually 4 laws are given. What are the laws? The first one is about the law of conservation of mass, law of constant proportion, law of reciprocal proportion, and last one is Gay-Lussac's law. But in your book, only 2 laws are given. One is law of conservation of mass and another one we are going to read about the law of constant proportion. The remaining 2 laws you will learn in your higher classes, right? So first, let me discuss about the law of conservation of mass. French chemist Lavoisier in 1774 discovered this, that is proposed this law of conservation of mass. This law states that the total number of products, okay, that total number of products are always equal to the total number of reactants during chemical reaction. Okay, it means that masses can neither be created nor can be destroyed during chemical reactions. So this law is otherwise called as law of indestructibility. Okay, you will learn about this in your higher classes. So mainly this law of conservation of mass states that the total number of product are always is equal to the total number of the reactants during chemical reaction. In the next video you will learn about the chemical equations, how to balance the chemical equation. So this law you can apply in that time. I will explain you in detail in the next video. Right, children? Good. So next one, we can move to the law of constant proportion. Right? Law of constant proportion was proposed by James Proust. Okay, Proust proposed this law of constant proportion. This law states that in a pure chemical compound, the elements are always mixed in equal proportions by mass. Okay. For example, you know very well, we get water from different sources. Water is obtained from different water, river water, well water, okay, like that. Here, the preparation of compounds may be different, but the composition will not change. It remains the same. It has fixed ratio. Okay. So this law is called the law of constant proportion, or otherwise we can say this law is called the definite proportions. Right, children? So what are the things we discussed today? Ions. Ions means what? Atoms which contains negative charge as well as positive charge are called ions. What are the two types of ions? One is the cations, another one is the anions. Anions are negatively charged, isn't it? And cations are positively charged, right? And next one is valency of ions, that is positive radicals as well as negative radicals. Different types of valent ions are there, like monovalent, divalent, trivalent, like that. Monovalent means element with only one valency. Divalent means what? Element with two valency. Trivalent means element with three valency. Okay. And we discussed about the valencies of some anions as well as some cations, right? Next one, what we saw? Chemical formula as well as molecular formula. Chemical formula is mainly used to identify the number of actual atoms which is present in the molecule of a substance. Okay. Next, naming a chemical compound. Okay. So what are the steps we saw? First we have to write the metals. Next we have to followed by the non-metals, and after that we have to add the suffix ate. If more number of hydrogen oxygen atoms are there, then suffix ate should be used. Less number of oxygen atom means suffix ite should be used. For some chemical compounds we have to use the prefix like mono, di, tri, like that. Okay, tetra, penta, like that. Next one, we discussed about two laws. One is the law of conservation of mass and law of constant proportions. Otherwise we can say law of definite proportions. These things we discussed today, children. So you go through all the topics. Okay, go through all the topics. Especially you should learn about the ions, cations and anions, and also how to write the valencies of cations as well as for anions, and how to write a chemical formula, how to name a chemical compound. These things are very important. Okay, when you go to higher classes it will be very useful for you. So don't omit everything. Okay, everything you have to go through once, and you will get the PDF. That also you copy down in your class of notebook, children. In the next video we can discuss about the chemical equation and also how to balance the chemical equation, and some activity parts are pending. That also we can complete in the next video. Okay, children. Thank you.